To find the derivative of a function y equals f of x from first principles, we need to find the value of the following fraction, f of x plus h minus f of x over h, as h approaches 0 more and more closely. That is, we need to find the limit as h tends to 0 of f of x plus h minus f of x over h. And that gives us the value of the derivative, f dashed of x, at the point with coordinates x, f of x, i.e. at the point P shown on this diagram. We are considering 2 points, P and Q, on the graph of y equals f of x. They are separated by h along the x-axis and f of x plus h minus f of x along the y-axis. H is the run between the 2 points, f of x plus h minus f of x is the rise. The fraction in the blue box is sometimes called the Newton quotient, and it gives the average gradient of f of x between the points P and Q, i.e. it gives the gradient of the straight line shown on the graph. In other words, the Newton quotient gives the value of rise over run for the chord PQ. And here we see that as h approaches 0, Q approaches P, and the gradient of the chord PQ approaches the gradient of the tangent line. And this gradient is the value of f dashed of x at P. And when we calculate a derivative from first principles, finding the limit is usually the hardest part of the whole procedure. Now sometimes we write delta x instead of h with corresponding changes to the graph, and then the rise and run become delta x and f of x plus delta x minus f of x, and we call the rise delta y. And we can read delta x as the change in x and delta y as the change in y. And with this new notation, the Newton quotient becomes f of x plus delta x minus f of x over delta x, which can also be written delta y over delta x. And when we take the limit as delta x tends to 0. And the notation for the limit as delta x tends to 0 of delta y over delta x is dy by dx. And this notation is meant to remind us that we found the gradient of y equals f of x by taking the limit as delta x tends to 0 of delta y over delta x. However, whereas delta y over delta x is a true fraction of real numbers, dy by dx is merely notation, and it is perhaps best to think of it just as the name of the function that gives the gradient of y equals f of x.